things ought I do first? You can't determine that down here at the asset level, where all I know is the configuration of the asset, the threats against it, and the potential risk score for it. That tells me nothing of the significance of that asset. The idea that I can take governance decisions and business objectives and refine them into a lens that IT can then use to be able to decide what do I do first and what do I do most urgently, where do I invest most aggressively, winds up being precisely what this can deliver. Now, this is a possibility. This is a methodology that has been used in critical infrastructure management, needs to be adapted to be applied to virtualization, but a very interesting one. So let's compare non-virtualized environments, and this is the last slide I'll dive into to open the floor for questions. Non-virtualized environments to virtualized environments. The non-virtualized environment, we always had to pay attention to applications and operating systems. More than that, we mapped our policies, external guidance from NIST, CIS, SAN, CERT, from anybody, and best practices into the configurations of these things, so that I did the best I could do, and I made sure I met regulatory mandate and I was consistent with my own policies. Easy enough? Now, how many ways could the settings here conflict with the settings here? That is, how many ways could the application collide with the operating system? Well, only a few, because they use exactly the same settings, right? So I could say the time to live that makes the operating system run efficiently is not the same time to live that makes the application run efficiently. If the application talks to lots of assets, I want a really short time to live, so I turn loose those kernel resources for those IP connections so I can use lots of them. If, however, the operating system talks to only a few because of shares, I don't want the overhead of tearing down settings and bringing them back up again for sessions, so I want to cache those. Those are at odds with each other in terms of kernel resource utilization. One setting is right, one for the other or the other, but they might be in conflict, right? Deeply virtualize that same environment, and we get a slightly different picture. Now I've got to map policy, external guidance, and best practices into all these levels of technology, all of which happen at different sorts of APIs with different settings, all of which have to realize a particular policy and set of perspective on this stuff, right? But ask the question, how can they interfere with each other? And I got a nice little combinatoric explosion out here, right? Because I can say, turn on full disk encryption here and affect service levels up there, if there is a penalty for doing full disk encryption, right? I can decide that I'm going to take my virtualization server and I'm going to implement a policy that partitions where I provision things, and that will affect the resources available to the web services environment that's going to be there. Lots and lots of interconnection here, and if I don't know where the interconnections are, I might take my checklist, assess this guy, see there's a problem, and change something, and what might happen? Unintended consequences, right? So let's leave it there. So what we've talked about today is that virtualization has some differences from non-virtualized environments, and that we almost always deploy virtualization in multiple layers. We've described a little bit about what some of those potential vulnerabilities are and what we do to manage them. More than that, we've described coupling, which is the idea that when we share in virtualized environments, a very important aspect of virtualization, that we complicate decision-making both about vulnerability assessment, mitigation and remediation, and ongoing provisioning in those environments. Then we talked a little bit about what that means in the final assessment from the big picture risk assessment and from the complexity point of view in terms of understanding that when we do virtualization, we've got more to do than we ever had to do without virtualization. The bottom line and the thing to take out of the session is that when you do deep virtualization, in order to get all the benefits of virtualization, you need to know more about configuration at more levels of abstraction than you ever had to know about when you weren't doing virtualization. That's a little counterintuitive because when it comes to provisioning's easier, right? I press a button, bang, I got a new system. That seems to have you knowing less, until you have to decide, where do I provision it? How's it configured? How's the rest of the stack configured? What's the security posture? All of a sudden, I've got to know more, and more across more disciplines. How many of your colleagues, friends, or co-students do you have that know a lot about SANs, a lot about virtualized storage, a lot about web services, a lot about SAP, a lot about Windows 2000 XP, Vista, and the alternative operating systems that might be in the stack? Note that where you specialize is where you're going to get really good. It's very hard to specialize across all of a technology stack. It means the guy you keep locked up in the closet, you probably need 2 or 3 of them in order to be able to do recommendations on this on an ongoing basis. Questions? Or insults? How many of you are interested in using virtualization or getting some deep proficiency in that for your environments? Go ahead. How many of you have any experience with virtualization, either Xen, VMware, ESX, Hyper-V, now that that's RTM? 0?
So we have a problem even if one of the virtual environment gets,
Sorry.
even if one of the virtual operating system gets compromised, then the whole system is at risk. Is that the thing?
No, that's potential. So
That's
there has
potential.
never been in the real world a compromise of a guest that has actually taken over a hosting environment and taken over therefore the co-hosted guests, at least not that we know of.
What if there is a problem in the virtual machine VMware itself?
Well, and there you get to the point. There are vulnerabilities which VMware and Xen and everybody else that builds hypervisors have acknowledged that if the vulnerabilities were successfully exploited, could allow arbitrary execution of code in the underlying hypervisor. So there's vulnerabilities. What I'm saying is essentially we haven't seen the massive attack that would hit the headlines nor that would be publicly noticeable. While the vulnerabilities exist and in principle have been demonstrated by security researchers, right? We have proof of concept. What we don't have is that having been a problem. Yet, it is the existence of a vulnerability that creates the responsibility on the part of a technology user to do something about it. It's not responding to the exploit, by then it's too late. It's responding to the vulnerability with appropriate controls and management so that you control the risk, the probabilistic exploit, not the actual exploit of the environment. So risk accrues and responsibility accrues by existence of the vulnerability, and they exist. Does that make sense?
Yeah.
Other questions? Thank you very much for your time in this. I hope it was useful. If you have any questions, my email address is on the back of these presentations, and that'll be posted. So don't hesitate. I'm intensely interested in this stuff, and I miss dealing with grad students and even undergrads. So thank you very much. Joel.